Derivative of sine of x, you guys just told me was what? Cosine of x. So if I move in this direction, it's going to be a derivative. So the derivative of the sine is the cosine. And the derivative of cosine?
Negative sine.
Is negative sine. And the derivative of negative sine?
Positive.
The derivative of the negative of sine has to be
Negative cosine.
negative cosine. And the derivative of negative cosine? Sine.
It's the way around.
Derivative of sine is cosine. Derivative of cosine, negative sine. Derivative of negative sine, negative cosine. Derivative of negative cosine, positive sine. Good. Product rule. It's been a while. Product rule. What's the problem? What's the product rule?
To the derivative of the first plus the second. No,
don't
times,
agree.
times the second.
Right. Product rule says it's the derivative of the first
Times the second.
times the second
Plus the first.
plus the first
Plus the derivative of the second.
times the derivative of the second. So everybody on the count of three, product rule says 1, 2, 3. Awkward. Okay, on the count of three, the product rule says, and then you just tell me what the derivative rule is. So the product rule says 1, 2, 3.
Derivative
Of the first
Times
the second plus
The first times the derivative of the second.
Okay, quotient rule. Think about quotient rule. Picture it in your head. On the count of three, we're all going to do the quotient rule, and we're going to do it like really loud in a clear, concise voice. We have a new teacher next door. I wanted to impress her. Okay, the quotient rule says low D high.
Minus high D low over low low.
Right. So one more time. On the count of three. 1, 2, 3.
Low D high minus high D low over low low.
Good. And then there was the chain rule. The chain rule was the composition, right? You have like a big function, and inside it you have a small function, the mama, and we get the baby. And the derivative of the chain rule says
Derivative of the mama.
derivative of the mama,
Leave the baby
leave that baby alone,
times the derivative
times the
of the
derivative of the baby. We got these things on lock, right? Perfect. The better you understand your derivative rules, the easier the rest of life gets. Adriana, do you mind reading the first word there is until?
Until today, our knowledge of integral calculus has only involved definite integrals. Integrals of the form of the integral from a to b of f of x d of x.
Or f of x dx, or f of x with respect to x. Okay, keep going.
We know from past experience that the sum integral from a to b of f of x in respect to
With
x
respect to x.
represents the area bounded by the function f of x, the x-axis, and the vertical lines x equal a and x equal b. In some cases, we have been able to evaluate the definite integral using our knowledge of geometry. In other cases, we have had to rely on our graphing calculator to evaluate this expression.
Okay, so I'm going to stop you right there. Just another quick little review. So if I said find the definite integral from a to b of t dt, this represents the one thing that this represents. There's only one thing I want to hear.
Area.
Look again.
The rate.
Oh.
If b of t is velocity, then this has to represent displacement. This represents displacement. Well done. Okay, and if there are absolute value bars there, we are no longer talking about displacement, we are now talking about
total distance.
total distance traveled. Now we went even further with the definite integral. Sometimes we did the integral from a to b of f of x dx, and then for some reason we divided by b minus a. And when you divide by the b minus a, what are you actually getting over here? Let's get a couple of hands on this. What are you actually getting if you divide by b minus a? I see 1, I see 2, I see 3, I see 4. Oh my gosh, why would you be dividing? Noemi, what are you finding here?
The average rate.
Not the average rate. Oh,
Average
the average
change.
value. The average value. You're finding the average value of this function. Now, I think there were some other problems that we did where we would do like the integral from a to b of r of t dt, and I'm picking r because I want you to be thinking about like rates. Right, rate questions like how fast water was going into a pool. Rate questions like how fast people were leaving an amusement park, things like that, right? If r of t represents how fast something was happening, then the definite integral always represents
How much?
how much, right? If R of t is how fast people are leaving the park, the definite integral then represents
How much? How many?
how many people left the park from A to B. Big picture, we're okay?
Yeah.
Okay, good. Jennifer, can you pick it up from there?
Oh, from where she left off?
Yeah.
We have also explored properties of the definite integral, worked on application problems involving definite integrals, rate functions, physics problems, etc., and uncovered possible theorems involving definite integrals, the fundamental theorem of calculus, and the average value of function.
Perfect. Thank you so much. So just a little quick check here. All the work we've done so far in the world of integration has been on the definite integral side of things. And the definite integral just looks like this. It's the integral from a to b of f of x dx. And you guys know, what's the question? What's the question being asked by this notation? The question is, how much? How much? The definite integral from a to b. When we first learned it, the first thing I told you is that this always meant area, right? This is how much area, but let's get the question right. How much area, give me a little bit more, how much area is between, or another way to say it, is bounded by four things. Careful, we're about to lose the crutches. By the, not x and y axis,
The x-axis.
the x-axis, that's one. What else?
X equals a.
Okay, x equals a, that's another one. And if you're gonna get x equals b, a, you're gonna get x equals b. So I've the x-axis, x equals a, x equals b. Eunice, what's the last thing? And the graph of f of x. And the graph of f of x. That's the question. Every single thing that you have ever studied in the world of mathematics, the notation is just asking a question. In this case, it's how much area is bounded by the x-axis, the function, and the vertical lines x equals a and x equals b. Big picture, we're okay? Totally a review. Totally a review. Now for the new stuff. Ranbir, can you pick it up from there?
Didn't we finish it?
No. It's just now.
Oh, now we need to add the indefinite integral. The integral of f of x to respect to d of x.
Okay, yeah. Something's different here. What's different here?
Indefinite.
It's an indefinite integral, not a definite integral. Something else is different.
Doesn't have A.
There's
B.
no endpoints. There's no limits of integration. It is a different notation. It looks the same. It's still an integral. But Daisy, the big thing, definite integral, you have limits of integration. Indefinite integral, no limits of integration. Ranbir, keep going.
In our toolbox of calculus concepts, the indefinite integral is a function which has f of x as its derivative. In other words, we are looking for the antiderivative of f of x. Mathematically, this means the following.
Okay, so if this guy over here, we're going to read this. How do we read this again? This notation?
Indefinite integral.
This is the indefinite integral. And you know it's the indefinite integral because there are no limits of integration. So I'm going to just say this is the indefinite integral of f of x with respect to x. Some people also know this, so it's street name, aka the antiderivative. So sometimes you're going to hear me call it the indefinite integral, sometimes you're going to hear me call it the antiderivative, same thing. Same thing. Yeah. Okay, so the indefinite integral of little f of x dx equals big F. Big F is really the antiderivative, and that's not a new word for us. And the c is a constant. Specifically, it's the constant of integration. I'm going fast in the vocab, but you guys are going to get that just fine. What makes big F so special, what makes big F the answer, Jose, is that big F, if I take its derivative, I get little f back. I'm going to say that lots today. So if I see this notation here, the indefinite integral of f of x with respect to x, the question that I'm asking you is this. What function has little f of x as its derivative. I am no longer asking you the area question. I'm asking you for a function, a specific function that has little f of x as its derivative. Is everybody okay in the difference between these two big questions? Okay, talk to somebody near you. Make sure you get the vocab right. Make sure your notes look good. I'm going to start pushing hard in the vocab. Make sure you got the two different questions right. What function has
derivative.
Okay.
So what's the antiderivative?
Right, but really you want to boil it down to what function has little f as the derivative. Little f is your target. We're learning to dance backwards today.
Well,
All right. And Giselle, at some point, can you make sure to remind me to tell everybody what the homework is?
Yes.
All right. So let's do two problems together, and then I want to get out of your way and let you guys play around with the calculus and build the smarticle particles. All right, Martin, can you read this first problem?
The indefinite integral of 6x minus 2 in respect to what?
Okay, the indefinite integral of 6x minus 2 with respect to x. What's the question? Like, we're going to come up with the answer, but what's the question? What's the math question that I'm asking here? Go back to your notes if you need to. Edgar, what's the question?
what function
function?
has little f as its
Let's be
derivative?
specific. What function has
6x.
6x minus 2 as the derivative? That's the question. I don't have to tell you anything else. Think about, go through this library of functions you have in your brain. Does anybody know of a function that has 6x minus 2 as its derivative? 6x minus 2 is your target. We're going backwards. What function has 6x minus 2 as its derivative? I see 1, I see 2, I see 3, I see 4. David, what do you think?
3x squared minus 2x.
Okay, David offers up 3x squared minus 2x. Does that work?
Yes.
Right? It works if you can answer the question, does this function have a derivative of 6x minus 2?
Yes.
Derivative of 3x squared.
Yep.
6x. Derivative of negative 2x. Negative 2. Good. Here's my question. Can anybody think of a different function that has 6x minus 2 as the derivative? Noemi?
X to the power of 6 minus 2x.
Okay, Noemi's offering up x to the power of 6 minus 2x. So let me throw this question back out. Does that work?
No.
Does this have a derivative of 6x minus 2?
No.
And the answer is
No.
no. Abraham, why not? Why are we not going to go with x to the 6 minus 2x?
Because once you do the power rule, it won't give the exact.
What is the derivative of this?
6x power.
6x to the 5th. Do you see it, Noemi? Okay, good try though. Eunice, you got one?
Yeah. Half x squared minus 2x.
A half x squared minus 2x is what you're offering up. Does that function have the right derivative?
No.
The way that you're going to figure it out, actually take the derivative in your head. Take the derivative of half x squared. Hold on. Oh, you weren't done?
Minus 12.
You're what?
She meant x to the power.
X to the 12th.
Oh,
Would
yeah,
be
good.
11.
Yeah.
But, okay, your power rule, though, is still going to cause a problem here, right? 12 times a half is 6, that's a good thing. But now you're running into Noemi's problem. Take 1 away from the power. Okay, is everybody okay? That one doesn't work? Got one?
3x squared minus 2x plus 3.
Oh, yeah.
Does that work?
Yes.
Does anybody else have a function that has 6x minus 2 as its derivative? Kimberly,
3x squared minus x squared.
3x squared minus x squared. Does that work?
Yeah.
No, because it'll be 2x.
6x minus 2x, not quite. Good try, doesn't work.
Instead
So
of
3x squared minus 2x works. 3x squared minus 2x plus 3 works. Ron Beer, what you got?
3x squared minus 2x minus 69.
Minus 6, yeah. 3x squared minus 2x minus 6, I'm just going to pretend I didn't hear him, right? So 3x squared minus 2x minus 6, does that work?
Yeah.
Yes. Anybody have another one that's not school inappropriate?
That was my function.
I bet you. Never mind. How about 3x squared minus 2x plus pi? How about generalizing it and just saying 3x squared minus 2x plus any constant? Because any constant, if I take the derivative is 0. This guy here is what I would consider like the best solution, 3x squared minus 2x plus, because we're all friends, I'm just going to call this guy Charlie. So the antiderivative is 3x squared minus 2x plus Charlie, but C is really constant of integration. And the new addition to the rule to help you remember Charlie, he's up here. All right, one more that we're going to do together, and then you guys get a chance to play. Take a minute, see what you can do at number 2. I want the antiderivative of 10 e to the t plus sine t plus 6.
So it's gonna be 6
Let me know when you think you've got it.
It's gonna be 6 plus negative cosine.
Oh, really?
You've got those derivative rules handy, and they're important ones.
You said minus cosine t? Oh, I see.
Remember, e to the anything is e to.
Okay, I've not seen the right answer yet. I've seen some close calls. David, what do you think? Oh, no. Some stuff I like, some stuff I don't like. Haven't seen it yet.
5e times 2t.
Remember, the question you're asking is what function has this as its derivative?
Right? Like
To the power of t. Yeah, that works.
10 to
Unless you wait.
So you have the t down here.
Oh yeah. Do we carry down the t? Like if it was 2t.
So your example is the derivative of 5 equals 2t 5
10
times
times
e
e
to
to
the
the negative
2t
t
times
What if you make it just negative 10 then?
Because we wouldn't be able to use that power.
Okay, I've seen the right answer once.
You do? You did?
Oh, who am I kidding? I can't see that far. Oh, so close!
Yes.
Oh, so close! Oh, sloppiness! Oh, sloppy! Okay, so I gotta pull everybody back together because I want you guys to get some practice time. Once we get this one under control, we got this. A lot of folks are focusing on like different pieces, right? There are pieces here that are easier than others. Like, for example, 6. What has 6 as its derivative? I'm sorry, what?
16.
It's derivative?
6t, 6x.
16.
Jennifer, how do you make the decision 6t?
It's d of
With respect to t, t is the variable. So all you 6x people, The 6 is easy. The sine of t, a lot of folks seem to be doing well with this. What function has sine t as its derivative? Negative cosine of t. This guy seems to be causing some problems. Now, here's what's happening. All of you that are taking this into pieces, you're doing something which is totally legal, but I don't even think you're thinking about it. What did I just do with that integral? I broke it up into like 3 smaller ones. I distributed that integral over like each of the 3 pieces, which, if you think back to Snoozerama, day 1 that we came back from winter break, and we went over properties of definite integrals, you can distribute the definite integral over addition and subtraction. Addition and subtraction, life is good for you. There's something else you can do that might make your life a little bit easy. This 10 over here, I know something about this 10. It's a constant. That means I can factor the 10 out in front of the integral. So all I need to know is what is the antiderivative of e to the t. What has e to the t as its derivative? Don't overthink this.
E to the negative.
Uh-oh. The derivative of e to the t, antiderivative of e to the t is
E to the t.
e to the t. So it's 10 e to the t. Antiderivative of this guy over here
Negative cosine.
is negative cosine of t plus the antiderivative over here, 6t. Don't be done. You're not done.
Plus c.
Don't forget Charlie plus Charlie. Now, right now, just for today and tomorrow, and then we'll stop doing this. Jose, you look so sad already. Okay? I want to check. I want to see the check step. I want you to show me that you know this answer is right. Just like back in second grade when you first learned how to subtract, and your teacher said, I want to see the check step, and the check step involved
Do it again.
adding, right? Because those are inverses. That's what I want to see over here. I want to see a derivative. Find me the derivative of 10 e to the t minus cosine of t plus 6t plus Charlie. Derivative of 10 e to the t, 10 e to the t. Derivative of negative cosine, positive sine, plus 6 plus 0. Check. Smiley face. The smiley face is optional. The check is not. All right. So between now and 4 o'clock, your goal is to get as far as you can on problems 3 through, I think it's 10. 10. In the last 4 years, I have never, ever, ever had an AB student correctly answer 9 and 10. Do not just jump there yet, just know that it's a challenge. Never seen an AB student get 9 and 10 right.
You gonna learn to do it.
Okie dokie. Mr. Special Number? I don't even know what that number means. Well, I'm gonna see the check step, and you can definitely help each other out. Still stuck.
Us too.
Oh,
No,
no, you're gonna drown on that side of the pool.
Oh, I want to drown.
Shut, no, I don't.
I'm gonna.
No one drowned? Stop out there. Okay, so who's still on pressure testing? Two, doc.
It has to be something to the power of 5. 0 to the power of 5.
4 over 0. 4 over 5.
4 over. No, but that'll give you 4 over 5. 4 over 5.
Equals 4.
This would be 4 over 5 x to the power of
Yep.
5. But wouldn't that be 20 over 5, which would be 4x to the 4th? 4 over x.
4 over 5. Because it's a fraction. It's 4.
Right, but wouldn't that be here, down here?
Yeah.
But this is x to the 4th, not 4x.
That's right.
But
Doing it like that would be 4x.
yeah, 4x to the 4th power.
Is there any derivative of 12 over 5? That would give us-
But that would give us one.
Let it reset.
Yeah, we said.
Yeah, it's your caption.
basically we just have to rewrite it.
Negative sign.
All right, so from what I've seen, there are parts of number 3 that are easy, and a part that's not so good. Anthony, is there a part that you feel comfortable with in number 3?
Starting off 3x to the 4th.
Okay, you are confident that the antiderivative of 12x cubed is 3x to the 4th. Feeling good about that part? I completely agree with you. Antiderivative of pi? Eunice, what you got? Plus pi x. Now last class where we struggled for a little bit is what on earth would I take the derivative and get x to the 4th? Is there such a thing? What would it possibly have to look like? Marvin?
Minus 1/5 x to the power of 5.
Minus 1/5 x to the power of 5. Yes. Does that work?
Yes.
Yeah.
Now, I'm not asking the question, did you see it? But now that it's in front of you, does it work?
Yeah.
The power rule says bring the power down in front. 5 times 1/5 is 1. And that's why it works. Right, there was that hidden, invisible little 1 in front, that little bugger that you just didn't see. So 3x to the 4th minus 1/5 x to the 5th plus pi x, like it, don't love it. Like it, don't love it. Plus c. I need that constant of integration. Good, keep going. Keep going. And then make sure you show me the check step over on the side. So you've got to make sure derivatives, Nice. But I want to see that check step. Not so bueno.
Negative cosine goes to sine, right? Yeah. We have negative cosine minus sine. And then plus c.
And don't forget about this little derivative wheel here. Derivative of sine is cosine, derivative of cosine, negative sine, derivative of negative cosine. Which means, what's the antiderivative of sine?
Negative.
Negative cosine.
Right? When you go in this direction, it's an integral. So if you need negative cosine, it must have come from negative sine. You can work in both directions as needed. Just know that clockwise you're finding derivatives, counterclockwise antiderivatives.
No, it's negative square root of x.
Daisy, is this your calculator?
The square root of x is the antiderivative of that, right? Where's it 1 over? For this one? Yeah, for this one. Square root of x. Oh, yeah.
Okay, and you sure? And I promise that there will come a time where it will stop. Right now, the check step. Roll. Hey, nice. I really didn't like ln. So I'm going to ask ln. Right, it's like you would never have a square root sign floating out there in outer space. So the square root of natural log of. Good.
I don't know how to do it.
Okay, so the check step, I'm asking you to find the derivative. What is the derivative of negative cosine?
Sine.
Right? Yes, all right, here's negative cosine. What's the derivative of negative cosine? Positive sine.
Plus x. It's just
So right here I should just put the derivative.
Right, that's what you're doing. This notation says I'm finding the derivative. The derivative of negative cosine is sine. The derivative of sine is cosine. And the derivative of a constant? Wait, derivative of a constant? 0. Perfect, just the way it's supposed to be. Okay, keep going. Friends over here.
X minus 1.
Square root of x plus natural log of x plus Charlie. Love it, love, love, love. Love it.
What about number 6?
Yeah, what about number 6?
Do we have to factor it out again in the next chapter?
I need that check step.
Never have time to think about the energies.
Oh, it's natural law.
Let me indulge in your time.
It's a natural law.
There's 50 chapters.
Okay, so if all goes well, and number 4, negative cosine theta plus sine theta plus Charlie. Number 5, square root of x plus natural log of x plus Charlie.
Yes.
How many guys got 3, 4, and 5 right? Okay, so we're in a good place. It is all about undoing derivatives. All about undoing derivatives. So let's look at number 6. 5 sine of x. What, oh what, would I take the derivative of to get 5 times the sine of x? If you're not sure, go back over here to the wheel. Adriana, what would you take the derivative of to get 5 sine x?
5 times the negative cosine.
Okay, I heard you say 5 times negative cosine of x. I'm more likely going to write that as negative 5 cosine of x. Does that work?
Yes.
The derivative of negative 5 cosine of x, the negative 5 is a constant, leave it alone. Times the derivative of cosine is negative sine. Negative 5 times negative sine, positive 5 sine x. Now for the mind-blowing piece. What, oh what, has negative sine 5x as its derivative? Negative sine of 5x. I see Rambeer. I hear Jose mumbling a little bit about, sounds like chain rule stuff happening in your head. Maybe. If I'm going to get negative sine 5x, Rambeer, what's going to happen?
You're gonna have to use the chain rule.
I'm going to have to use a chain rule. What would I take the derivative of to get negative sine 5x? There are pieces that should be a little bit easy. Marvin?
Negative cosine theta?
Okay, so I've heard negative cosine of 5x. And the question is, does that work? Does negative cosine of 5x have the correct derivative?
No.
Let's go off on the side. Like, this is the check step that I want to see. The derivative of negative negative cosine 5x. The derivative of negative cosine of stuff is positive sine, leave the stuff alone, right? This goes back to Jose's chain rule. Sine of the angle, don't stop there. Times, not the baby, times the derivative of the baby. Look at what you want. What you want is negative sine 5x. There are places that I'm close, and then there are places that I'm far away.
You're close.
I'm close, thank you. I at least have the sine part coming out right. But I don't want positive sine 5x, I need negative. So let me switch this to positive cosine 5x. Now that's good, that's better, but that's not right. The reason that I'm not getting the right answer, I've got negative sine 5x times 5. How can we fix that? Tomorrow, like, the rules will come and we will memorize all the right things. But the question is, how do I get rid of this times 5? What do you want to do? Move it, like, up, move it out in front? But the problem is, my goal is to get negative sine 5x. What I'm getting is negative sine 5x times 5. I don't want the times 5.
Is it 1/5 cosine?
If I make this minus 1/5 cosine of 5x, now take the derivative. The derivative of negative 1/5 cosine 5x is negative 1/5. Derivative of cosine? Oh God. No.
Negative.
On the bottom.
The derivative of cosine
Negative sine.
is negative. So negative a fifth times negative sine, I think I like that part, of 5x. Wait, oh, so awkward. Plus, my bad.
Yes. Base point.
Sure. Except, I think I probably owe you a detention as well, so we'll just have them cancel. Okay, 1/5 derivative of cosine is negative sine, 5x, times 5, with this 1/5 in front. That works. All right, that didn't go as smoothly as I hoped. All right, we got 4 challenge problems that I want us to play around with. These last 4, I will tell you right now, you will find none of these in on your handout. We're not going to have any conversation about 5, 6, 7, and 8. We don't have time for that. We're just going to play with 1, 2, 3, and 4. The integral works nicely, really nicely with addition and subtraction. It doesn't work nicely with division. If you see multiplication or division in the integrand, I want you to know you got bad news here. We cannot, there are no easy ways to integrate x plus 1 over x squared dx. Because the integral doesn't have any nice properties with division. But algebra cleverness always goes a long way. For example, is this equal? X over x squared plus 1 over x squared dx. Is it legal?
Technically.
Yes, because you're dividing both of them by x.
I'm dividing both terms in the numerator by x squared, so I'm just finding a new way to write it. But why would I do that? Legal, but is this better?
Yes.
Ron sees it, Jennifer, you see it? What's better about this way?
Now you can do it the same way as like the ones we did before. Like you can do it 1 part by 1 part.
Okay, I think there's also something happening here that you haven't picked up on yet. This guy over here. X over x squared, you have another way that you can play around with this. David, what could you do?
It's 1 over x.
It's 1 over x. And why do we like seeing 1 over x in the integrand? Right? The question is, what has 1 over x as its derivative?
Natural log.
Natural log of x. My question, what has 1 over x squared as its derivative? Jasmine, hi. What has 1 over x squared as its derivative? Go check that table if you need to.
You can just yell it out.
Now hold on, check the table. What would have 1 over x squared as its derivative? There is something.
It's at the top.
There's something. It's close. It's not perfect. Remember, help me out.
Negative 1 over x.
Okay. The derivative of 1 over x is negative 1 over x squared, but I need positive 1 over x squared. So try that instead. Natural log of x minus 1 over x plus c. Just for the sake of completion, because other folks are going to watch this video and be like, oh, he did it wrong. Tomorrow we're going to come back and have a conversation about the natural log of x. For right now, this is the right answer. Tomorrow it's the wrong answer. But for right now, it's the right one.
Just because of natural log. Right?
Because of the natural log. We'll talk more tomorrow. Don't miss class. All right, number 2. I've got the integral of x times x squared minus 4 dx. When you see multiplication and division in the integrand, it is bad news. Your way around this is always going to involve algebra cleverness. Go try some algebra cleverness. And just here to make sure I talk about tonight's homework. Algebra cleverness. I want legal things that make your life better.
You could do 1/4 times x to the 4th, right?
The integral of x times x squared minus 4. I've seen a lot of folks that have distributed the x and they said it's x cubed minus 4x. Is this better? I think so. Antiderivative of x to the 3rd. What would have x cubed as its derivative?
X to the 4th.
1/4.
1/4 x to the 4th power. Minus what has 4x as its derivative?
2x squared.
This has to be 2x squared. Don't forget Charlie. Nice job. Tomorrow, the rules are coming. We're going to spend a couple of days here and just get a lot of practice. All right, number 3, we're going to dedicate this one to Mr. Salhotra. The antiderivative of sine squared of x plus cosine squared of x with respect to x. Hooey! Multiplication's bad. Division's bad. Trig, I know it just makes some of you want to throw up.
That rule, sine squared plus the cos squared equals 1.
Jose, what was the cleverness that you just had? 1, like I'm number 1, thank you. The integral of sine squared of x plus cosine squared of x. You guys know there is a better way to write this. Sine squared of x plus cosine squared of x always is 1. So this is the integral of 1 dx, and so my question to you all is, what function has 1 as its derivative?
C.
Not c.
X.
X, or better, 1x if you need to see it that way. There are going to be some integration rules that are just see it on site and others that you have to work for. All right, one more. Show me what you can do with this one. Integral of e to the x plus e to the negative x squared with respect to x. Multiplication's bad, division's bad, exponents, that's just a fancy way to multiply. I need legal stuff. Legal stuff. Only show me the legal stuff.
And then you have 2 that cancel out right here. I know that much.
Yeah, e of x.
Wow, I'm seeing all the ways no one taught you to multiply. I'm seeing some versions of the box
Wasn't it?
that,
What the heck?
yeah,
What the heck?
that's what I'm thinking. E to the x plus e to the negative x, e to the x plus e to the negative x. Oh, it's exponent rules that are getting us here. E to the x times e to the x is t, the bases are the same. E to the 2x, e to the x times e to the negative x.
It doesn't matter what it does.
Careful. It does matter. E to the x times e to the negative x. Careful. E to the,
Negative.
what's the exponent?
Negative x.
Add the exponents.
Negative 2x.
It's e to the 0, which is really 1. This box down here. E to the negative x times e to the x. E to the 0. That's 1 again. E to the negative x times e to the negative x. Add those exponents. E to the negative 2x. Now I want to be careful. When you're rewriting the integral here, it's e to the 2x plus 1, so that's plus 2, plus e to the negative 2x dx. This is not your final answer. Your goal was to rewrite the problem so that you didn't have multiplication and division happening. So my question is, what function has e to the 2x as its derivative? What would have e to the 2x as the derivative? It's going to have to be e to the 2x, but times a half because of the chain rule. Plus, what has 2 as its derivative? 2x. Plus, what has e to the negative 2x as its derivative? E to the negative 2x with a negative a half in front, and then plus Charlie. You guys seem to be fine with 1, 2, and 3, but not number 4. All right, tonight's homework that Giselle was going to remind me about. Okay, we can stop filming.